You think you're funny, do you?
So, the things my ragamuffins need to know about using the distributive property to break numbers apart whenever they're trying to multiply a small number by a large number is that every digit in the number has a certain value, and that value is determined by the place that that digit has in the number. So in the number 136, the number 3 sits in the tens place. So 3 times the place value, 10, 30, becomes the value that the digit 3 brings to the whole number. Once you know that the digit next to on either side is either 10 times greater or 10 times smaller, then you can break the number apart and multiply effectively using the distributive property. So the situation we're going to look at today has to deal with a character named Henry. And Henry is a chicken farmer. Well, not so much a chicken farmer as he likes to produce eggs, which he sells. So he's got 55 hen-laying eggs, and every day they lay 1 egg. We need to find out how many eggs they produced after 1 week. And then when he sells the eggs for $4 per dozen, how much money does he make? The only way we're going to find out how much money he makes is by understanding that in 1 week, we've got 7 eggs for each of his 55 hens. Because the question clearly says after 1 week. Then he's selling them for $4 per dozen. A dozen, of course, is 12. How much money is that? So using the distributive property, we know that any number A times B plus C is going to equal to that number A times B plus A times C. And if that isn't confusing, I don't know what is. So let's take a look at a quick example. If it's 4 times 12, that's the same as multiplying 4 times 10 plus 2. The digit 1 sits in the tens place. So when I multiply 4 times 10, and I add it to 4 times 2, I get 40 plus 8, or a total value of 48. So let's look carefully at what we know about this situation. Whoa. Turnaround rule. That's not the turnaround rule. The distributive property is the break apart rule. The turnaround rule is the commutative property. And it says that 2 plus 3 is the same as 3 plus 2. Or, in the case of multiplication, we could say that 2 times 3 is the same as 3 times 2. We basically do not care what the order is of the addends if we're finding the sum, or the factors if we're finding the product. So, with the distributive property, we're actually breaking the number apart based on the value of each digit in the number. It's called the break apart rule from 2nd grade. So, my bad. The first thing that we have to find out is how many eggs did those very agreeable hens lay in 1 week? We had 55 hens, each hen laying 1 egg per day. That's a lot to ask. That's 55 eggs in 1 day. The question stated how much money did he make in a week? 7 days. At 55 eggs per day makes me think of 7 groups of 55. 7 times 55, in fact. I know that 55 can be broken up into 50 plus 5, and then I multiply 7 times 50, and I add it to 7 times 5. So 7 times 5 is 35, so I know that 7 times 50 is 350. When I add it to 7 times 5, which is 35, I get a total of 385 eggs. Now that I know that there are 385 eggs, now I have to sell them at $4 per dozen. Well, if I know that I've got 385 eggs and $4 is what I'm going to get paid for 12 eggs, I have to find out how many dozen eggs do I have? How many groups of 12 eggs? If I take a look at my total number of eggs, which is 385, and think, well, how many dozen is that? So let's look at this. I'm going to have to put 385 into groups of 12. This is a division problem. I have to divide 385 by 12. And then, however many groups of 12, however many dozens, I'm going to collect $4 for each dozen. So let's take a look at a method of division, which can be also compared to repeated subtraction. I'm going to put 385 as my dividend, and I'm going to clearly show 12 as my divisor. And then I'm going to subtract multiple groups of 12. So I look at this and I think, well, 10 groups of 12 is 120. Let's subtract 120 eggs. That's going to leave me with 265 eggs. But that's enough to take another 10 dozen eggs out, so that's going to leave me with 145. I can group another 10 dozen eggs. That's going to leave me with 25. Well, 12 times 2 is 24, so that's 2 more dozen. And that's going to leave me with one sad little egg all by itself. I'm thinking Henry's probably going to eat that egg. Knowing Henry, at least. So the total number of groups of 12 is 32 groups. I just simply add up my partial products. That means I have 32 dozen eggs. The next part of the problem is, how much money am I going to get for all of those eggs? 32 dozen. The distributive property has allowed me to break apart those numbers to get a total of 385 eggs, which I then divided into groups of 12, and now I know I'm working with 32 dozen eggs. Now I'm going to get $4 for each dozen, so that's going to make me multiply 4 by 32. Again, I can use the distributive property here, and that's going to allow me to break 32 apart into different values depending on what value each digit brings to the number. So let's use an area model to show what that total is. With an area model, I have one rectangle that's going to show me 4 by 32. The thing is, I don't know what that area is, but it's going to represent the total amount of money. So here's what happens. The area model helps me break up the number into partial products. I'm going to break up 32 into 30 and 2. And then I'm going to show that I'm multiplying 30 and 2 by a factor of 4. $4 for each of the dozen eggs. When I look at the area of the larger rectangle, I'm multiplying 4 by 30. And 4 by 30, I'm going to add it to the area of the smaller rectangle, which is 4 by 2. $128 again. $4 by 30, the larger of the two rectangles, has an area of 120, and the smaller rectangle has an area of 8. When I get the sum of the partial products, I get $128. So now it's up to you to pause so that you can practice this problem, work it out completely on your own, and then check back to see if we've worked it out the same way. So your situation is 48 hens. Each hen, again, laying 1 egg, same time period of 1 week, but now instead of $4 per dozen, you're going to be selling for $5 per dozen. I'm going to break this apart into 2 sections to find out first the number of eggs, and the second part of the problem is going to help us figure out the total amount of money made, just like before. So if I have 48 hens over a 7-day period, I'm going to multiply 7 by 48. 7 times 40 plus 7 times 8. 7 times 4 is 28, so 7 times 40 is 280. 7 times 8 is 56. The sum of the partial products, 280 plus 56, is 336 eggs. Now I'm going to divide by 12 to find out how many dozen eggs I have, and then multiply by 5 to get the total amount of money that I've made. Again, I'm going to use the partial quotients method or repeat subtraction. I subtract 10 dozen, that leaves 216. Another 10 dozen leaves me with, let's see here, 96 eggs. I remember my 12 times table. 8 12s is 96, leaving nothing. So I add up the sum of my partial products. I get 28. I have 28 dozen eggs. Now I have to find out how much money am I going to make by selling 28 dozen eggs at $5 a dozen. This makes me find the product of 28 and 5. So 5 times 28 is 5 times 20 plus 8, which is the same as 5 times 20 plus 5 times 8. That gives me 100 plus 40, $140. Awesome. We know that Henry sold 28 dozen eggs and made $140. What are you going to do with that money, Henry? So here's what I understand. I can use the distributive property, or the break-apart rule, to multiply smaller numbers by larger numbers, looking at the value that each digit brings to the number, and I multiply my initial factor, the smaller number, by each of those values. I get the sum of the partial products, and that allows me to find the product of the whole number that I started off with. I find that the distributive property is extremely useful if you are estimating or doing any mental math. It really lets you know what if your answer is reasonable or not. So you can use it that way, or you can actually use it to break apart the numbers before we get to the multiplication algorithm. All right. I hope that helps. And Henry, keep taking care of those chickens. All right. Bye.
I need to know everything. Who and the what and the where. I need everything. Trust me, I hear what you're saying, but act like it's new what you're telling me. I'm curious, George. I hop in the Porsche, 5 and a horse. I'm ready for war. I'm coming for throats to turn to a ghost. I need to know everything.